Today we're going to learn a really fun rule called the law of sines. And first slide, I'm just going to prove to you why it works, but then in the subsequent slides we'll do examples. So let's say I had a triangle and its sides were side A, side B, and angles A, B, and C, and its sides were small b, small a, and small c. If I were to write the sine function, the sine of angle B is equal to B over A, and the sine of angle C is equal to C over A. That's just by your opposite over hypotenuse rule. Okay. So then, if I were to take this part right here and cross multiply, I would have A equals B over sine B. And if I cross multiply this part, I would get A equals C over sine C. And now these are both the same, so I can say B over sine of B equals C over sine of C, which if I then flip upside down, it becomes the law of sines. And so our law of sines actually looks like this. It says sine of angle A over side A equals sine of angle B over sine B equals sine of angle C over side C. And this rule, although I'm not going to prove it right here, actually generalizes to any triangle. And so it doesn't have to be a right triangle. And we'll look at that later. But for now, it doesn't have to be a right triangle. This is just a law of sines. The only thing weird about it is you don't have like a 3 equal sign thing. You just pick 2 of them. Like you could pick these 2 to be your law of sines, or you could pick these 2 to be your law of sines. So just pick 2 of the sides. You will use the law of sines rule when you have problems that have sides and angles where the sides and angles are opposite of each other. So an example of when you could use this law of sines rule is if you had angle A is 25 degrees and side A, and let's say angle B is 75 degrees. So here's a 75 degree angle. So there's B and there's A. And side A is 14, and we need to know how long side B is. So if I think about this from a geometry perspective, this is an angle, side problem. And for angle, side problems, there's only one possible triangle you can draw, and so this problem would only have one possible answer. And I would find it by going sine of 25 degrees over 14 is equal to sine of 75 degrees over x. This is a calculator question. I'm not going to solve it for you because I figure you're pretty good at that. But from there, you just cross multiply, get out your calculator, you're all done. So now let's review geometry. We had our side rule of 3 sides of a triangle the same as the other 3 sides of the triangle. The triangles are congruent. But we can't use law of sines here in a side problem because we need to have 2 sides and 2 angles. We don't have any angles. Side angle side, we also can't use because in a side angle side problem, we don't have the side that's across from the angle. Like if you're looking right here, in the law of sines rule, the sides and angles have to be across from each other. They're not. And so here in this problem, we can't use law of sines. Okay. If we have an angle side problem. Now, so if I look at the angle side problem, let's say I've got this angle, I've got this angle, I've got this side, and so these 2 are across from each other. I can use the law of sines to solve for x because, let me give these some letters. Let's say this is A, and this is A, and this is X, and this is X. I could write an equation that said sine of angle A over side A is equal to sine of angle X over side X. Now our next geometry rule was angle side angle. So angle side angle is a triangle that would be marked like this. Here's an angle, here's a side, here's another angle. Angle, side, angle triangles are always congruent. And if I look at where I have opposites, even though I don't have the angle opposite here, I can figure it out. I can go 180 degrees minus the two different angles. So, and I get that angle, and now let me give these labels again. Let's call this W, P, and Q. So I can figure out angle Q by the other two angles, and then I can do sine of angle Q across from side Q equals sine of angle W across from side W, and I can figure out what the side W is. So to summarize, can't use law of sines, can't use law of sines, can use law of sines. But there's a couple of other situations that we can use law of sines, and we can use law of sines in that angle. Well, actually, let me do one more easy example. So let me do an example of an angle-side angle problem. So I'm given a triangle, and my triangle looks like this. And this is 40 degrees, and this is 80 or 91 degrees, let's say. And this is 15, and how big is x? Okay. To use the law of sines, I need the sides and angles that are across from each other. So 40 would go across from the x, but I don't have what's across from the 15, but I can figure it out pretty quickly by taking 91 plus 40. That's 131. Taking 180 minus 131, and 49. And so now I have the angles, and so I'm really sort of looking at them like 40 is across from x and 15 is across from 49. I'm not going to use the 91 because it's not across from anything. And so, like, if you kind of thought about it, let me find a different color here. It's like you're just sort of drawing an x out of the problem. I'm going to use these two, I'm going to use those two. So I have sine of 49 degrees over 15 is equal to sine of 40 degrees over x. Now, when you cross multiply, you get x times the sine of 49 equals 15 times the sine of 40. And then if you're using a graphing calculator, just make sure you close your parentheses in the right spot. So when you type this in, it would be x is equal to sine of 40, put the parentheses around the 40, times 15, divided by sine and 49. And the 15 could come before the sine 40. And if calculators in degree mode, you'll get an answer. Now, remember when your geometry teacher, which may have been me, said do not use bad words in geometry class? The reason is because if you're given a situation where you have a triangle and you're given angle side side, let's say this angle right here is fixed. Let's say that's 30 degrees. And let's say that this side is fixed. This is 15 long. And now, a little bit strangely, let's say it's this side that I just erased that isn't fixed. That is fixed. But the problem is I don't know if it's here or if it's there. So I have two possible triangles. I have this triangle, which is an obtuse triangle, and I have this triangle, which is an acute triangle, and this side is the same as this side, and this side is the same as this side, and these angles are both 30. So we're dealing with a non-right triangle. We're dealing with an angle side-side situation, and we don't know what that other angle is. It could be a small angle if it's this triangle, and it could be a big angle if it's this triangle. So if we tie that information back into what we know about the sine function, because this is the law of sines, we know that if we take the inverse sine of an angle and it's positive, we could get an answer like 40 degrees, but we could also get an answer that's 40 degrees away from 180 as 140 degrees. So if you find yourself solving a triangle that has an angle side-side situation, then you need to give two possible answers, one answer that has the larger angle and one answer that has a smaller angle. Here's an example of that situation. I'm solving this triangle and I want to use law of sines because if I look at the triangle, the 40 degrees is across from the 11 and the 15 degrees is across from the question mark. And I should be able to set it up and go sine of 40 over 11 is equal to sine of x, or in this case b, I'll use b, over 15. All good, get out my calculator, and I can cross multiply and get the answer. Okay, so let's make that happen. I'm going to make this a little bit smaller. And I'm going to type into my calculator, let's see, I've got 15 times the sine of 40 equals 11 times the sine of b. So I'm going to type into my calculator 15 times the sine of 40, make sure I close my parentheses, divide by 11. I get 0.87 equals the sine of b. Now remember, if you're using your calculator to find an angle, you're going to press the inverse button. So I'm going to do the sine inverse of 0.87 to get angle b. And my calculator tells me, wait for it, there we go, 61.22 degrees. Okay, but I need to think. This was a side-side angle problem. And so I don't actually know if I have a 40-degree angle, so I could have 40 and 15 and 11, or I could have 40, that's 40, and this is 15, but the 11 goes this way. That's not very to scale, obviously. So if I have this situation, call situation 1 with the acute angles, then this is 15, this is 11, this is 40, and I just found my answer, 61.22. Okay, but if it's the other situation and I'm looking at this acute angle right here, then I'm looking at 180 minus 61.22, or 118.77 degrees for my answer. Two possible angles for that answer, 118 or 61. Now, you don't have to worry about these other possible answers in a situation other than angle side-side. So when you're given information, sketch yourself a picture. If it comes up with only one possible triangle, like it was nice in geometry, then you just cross multiply and solve. But if you have an angle side-side situation, then you need to do some more work. And on some problems, it'll be even more work because it says to do something called solve the triangle. Solving the triangle involves finding all of the angles and sides. So if you have this nice acute triangle, you're going to take your 40 and your 62.22, and you're going to add them together. That's 102.22. And you're going to subtract that from 180. And you get 77.78, that's this angle. So if I wanted to find this other side here, here's angle A, here's side A. To find side A, I'm going to use law of sines again. Sine of 77.78 over side A equals sine of 62.22 over 15. But if I had the, you can think of this as the acute option. If I didn't have that acute option, not obtune, if I didn't have the acute option, and I instead had the obtuse option, then the angle down here is my 118 degree angle. And so it's going to be sine of 40 over 11 equals, and I'm going to have to figure out what this angle is right here. So I'm going to take 40 plus my 118.77, subtract that from 180. This angle is 21.23. This is side A, equals sine of 21.23 over side A, cross multiply, get that answer. So all in all, it should be a pretty easy homework assignment. You're going to draw the picture, decide if it's the easy problem where you just use the rule, or if it's that hard problem, if it's the angle side side problem, you're going to have two pictures. One for the acute rule, one for the obtuse rule. After you do that, you set up law of sines and solve the problem. So for this problem, it says angle B is 95 degrees. So I'm going to make a 95 degree angle. It says the side across from it is 130. And it says angle C is 35. And it says to solve the triangle. So if this is angle B and this is side B, and this is angle C, I'm going to also need side C, angle A, and side A. And so I will first take 95 plus 35, that's 130, subtract that from 180, and I get 50. So right now I have this angle, and now I'm going to solve this problem using law of sines. Now, if I look at the information I was given, let me put it on here in red, I was given an angle and a side. An angle, angle, side only results in one triangle. And so I just solve it. Sine of 35 over side C is equal to sine of 95 over 130. And I get out my calculator, and to get C, I am just going to type in sine of 35, close the parentheses, times 130 divided by sine 95. I get C equals 74.84. And I have the angle C, the big C, is 35 degrees. So they gave me A and B, and I've got C. Oh, I've got angle A, the big A, is 50. I need one more equation for sine of A. So sine of 50 over A equals sine of 95 over 130. I get out my calculator, I type in sine of 50, close the parentheses, times 30, divided by sine of 95, and I get A is 23.07, and I've got my C's, I've got my A's, I was given my B's, the triangle is solved. And on a last note for that, the angle side-side scenario, what happens is when our calculator outputs angle theta, it turns out that these two black lines right here represent the two different positions for that third side to be in. And because they'd have to be the same length, that creates an isosceles triangle. So this angle is also theta, and by linear pairs, you can take 180 minus theta to get alpha right here. And so I didn't explain why I did that step, but if you do have an angle side-side situation, this is the angle that your calculator is going to give you. You take 180 minus that angle, and you get the other possible angle.